I can't see the difference between the ground and your foot. Here we go, Unit 5 review. Okay, this is part 2, okay? I did part 1 yesterday, so if you want to take a look at that, not on the binder. We're up to 50 now. All right, so that's Joe, everybody. Joe Singleton. Okay, so we're going to go through each of these questions that you had the privilege of working on, and we're going to go through them. If you have questions, please ask. So if y varies inversely with x cubed minus 1, okay, first of all, we write the equation. Remember that this statement right here, y varies inversely, is equivalent to y equals k divided by. Okay? Varies inversely means k divided by. Well, k divided by what? K divided by x cubed minus 1. So, k over x cubed minus 1. Now, the second piece of this is they give us some information. However, a lot of people here struggle with which value goes where. Remember, f of x is function notation from Algebra 2, which means the x value is negative 1. Okay, so the x value here is negative 1, which means 7 over 4 is what value? The y value. Okay, so we substitute for x, we substitute for y, and then that will allow us to solve for k. So 7 over 4 equals k divided by negative 1 cubed minus 1. And then from there you simplify. 7 over 4 equals k divided by negative 1 cubed is negative 1 minus 1 is negative 2. This is called a proportion. Two ratios equal to one another. To solve a proportion, we cross multiply. So we get 4k equals negative 14, which means k is negative 7 halves. The reason we do that is so that we can take that value now and substitute it for k in our original equation. If you want to leave it as negative 3.5, I don't care. All right, that's still okay. Technically, fractions inside of fractions isn't really a good thing anyway, but for this, you don't have to simplify that. And then the last part of this is saying, okay, now once you've done that, find f of 1/2, which means we're substituting 1/2 in place of what variable? X. And then we solve for y. Here we have a rational expression or a rational function, 3x minus 1 over x minus 1. We need to rewrite that into this form, the form of a hyperbola, all right, from Algebra 2, and then evaluate the limit statements based on the equation. Okay? So first things first, anytime you're rewriting this, my biggest recommendation is to just write the denominator in the numerator. Just put it there. And then ask yourself the question, what do I have to do to that to maintain equality to the original problem? So the original problem is 3x minus 1. What would I have to do to this x minus 1? There's two options here, one that takes multiple steps, one that takes 2 steps. Lindsay, what would I do? Perfect. Okay, so in doing that, Lindsay achieves some of what we want. 3 times x, all right, 3 times x is 3x. However, in solving one part of the problem, she creates another problem. 3 times negative 1 is negative 3. We don't want negative 3. We want negative 1. So what will we have to do to maintain equality, Lindsay? Add 2. Okay? So, next step goes back to day 1 of this discussion where, my 10 minus 5 divided by 2 rule. All right? You cannot just take 10 divided by 2. I realize they are divisible, but that's not how this works. Okay? Everything in the numerator is getting divided by 2, which means the negative 5 is divided by 2 as well. Same thing applies here. Both of these are getting divided by x minus 1. So you need to express it that way. So 3x minus 1 divided by x minus 1 plus 2 over x minus 1. What is a very common mistake in this step right here? What are people very tempted to do? Destiny? Cancel out the x minus 1s. Oh, 3 plus 2 is 5. No. All right, that's not how it works. Both are getting divided by x minus 1. Now, in this step, the x minus 1s do cancel each other out. And we're left with what we need in the original, which is y equals 2 over x minus 1 plus 3. Then we need to evaluate the limit statements. Okay? Now, you don't need to use a graph for this, but you can. If you are better at using a graph, then sketch a graph. Right 1, up 3. Okay? And that tells you your asymptotes. Okay? And then use the graph as a reference. Obviously, you could spend a little more time sketching it more accurately than I did. Okay? But we're going to do this without the graph. You could obviously use a table as well, by the way. Okay? What I want to do is talk about this conceptually. X is going to infinity. So if I put infinity in here for x, I'm going to have 2 divided by infinity minus 1 plus 3. What is infinity minus 1? It's still infinity, okay? And any number divided by infinity equals what? So something over big equals small. And by small, we mean close to 0. So this is basically, this right here is 2 divided by big, which equals small. Remember, small is 0. So 0 plus 3 equals 3. So the limit of f of x as x approaches infinity equals 3. All right? Infinity is big. Anything divided by a really big number equals a small number. Then by small we mean 0. 0 plus 3 is 3. Okay? Now let's try the other one here. Okay, this one gets a little trickier. As we're approaching 1 from the left, okay, that means we're just a little bit smaller than 1. So what's a little bit smaller than 1? 0.99999 something. Okay? So 2 divided by 0.999 minus 1 plus 3. Well, what is 0.9999 minus 1? 0, okay? Or a number really close to 0. It's actually like a negative 0, right? Okay? Plus 3. And any number divided by a negative, now Ryan says 0, when he says 0, he means what? Small. So we have a negative small number. So, something divided by small equals big, and in this case it's negative. How did I know it was negative? Because this number is smaller than negative 1, right? So a negative small number equals a negative big number, which is negative infinity plus 3. What is negative infinity plus 3? Negative infinity. Okay? Again, if this is all confusing you, just draw a graph. And put your fingers in the lines, go towards 1, go towards 1, whatever you have to do. Okay? You could also use a table, by the way. All right, we could use a table for this. Use your table start at 1, delta table 0.0001, and go to your table. You're going to see one of them is going really big, one of them is going really small. Last one here. Okay, we have 2 divided by 1 from the right would be a little bit bigger than 1. Whoops. So 1.0001 minus 1 plus 3. So this 1.001 minus 1 gives you a small number. So 2 divided by small plus 3. And any number divided by a really small number equals infinity. And infinity plus 3 equals infinity. And again, people, that's what we would have gotten had we had drawn the graph. Because remember, we had asymptotes here and here. And this is what our curve looked like. Because it's a hyperbola. So you can see right here, on the line, going to infinity, what y value am I getting closer to? I'm getting closer to my VA, which is at 3. On the line going towards 1 from the right, so here is, some of you are asking, well, how do I know what I'm doing here? Well, there is 1, it's an asymptote. So if I'm on the right side of 1, I'm over here. I'm going towards it on the road, which is the line. As I get closer to that asymptote, where is my y value going? to infinity. It's pointing up. It's never going to stop. It's going to keep going. On the left-hand side, I will be on the left side of this asymptote. Now I'm on this line going towards 1, and that arrow is pointing down, which will be negative infinity. And again, that's the two answers we got here. So if using the graph is easier for you, use the graph. So finding a limit using a table just requires that you use your graphing calculator. You need to go to table set. So take out your calculators right now, please. All right. And then table start will be whatever x value you're approaching. So here we're approaching the x value of 2. So table start will be at 2. Delta table changes each time. The first time you want to count by 0.1. And when you go to your table then, you're going to get a value for 2.1 and a value for 1.9. And then you want to go back in and change that to 0.01. And that'll give you a value for 2.01 and 1.99. Okay, and then you want to go back one last time and change that to 0.001. Every time, make sure you're starting at 2, and that'll give you a value for 1.99 and 2.01. Once we have all those values filled in, we can determine the limit. Once we have those values from our calculator, we need to look at the limit as we approach it from the left, and left is smaller. So 6.9, 6.99, 6.999, I would say is going towards 7. Okay? From the right, which would be the bigger numbers, I have 7.1, 7.01, 7.001, which means it's going towards 7. So what is the limit as x approaches 2? 7. Does the point 7 exist, though? When you go to your table at 2, what is there? There's an error. Okay? There is an error. That means there's a hole in the graph. If you were to draw that graph, it would look like this. All right? If this is your xy plane, and that's 2, and that's 7. So the point doesn't exist. However, the limit on the line coming from both sides does. Remember, the two do not depend on one another. All right? If you graph this on your graphing calculator, it's not going to show that hole, by the way. You would have to zoom in quite a bit to be able to see it. All right? The table is going to be what shows it to you. This is on the test. You have to know how to use the calculator. You got to know how to type the equation of y equals, and you got to know how to manipulate your table to get what you want. And you're going to have to fill in the table in the test. And you're going to have to show me from each side what it equals. Okay? What if these two numbers would be different? Then what? Then the limit would not exist. Does not exist. Okay? These two numbers have to be the same. Okay? All right, so if we have a piecewise function, so we're determining limits from a graph. Hopefully this is one of the easier ones on the test. You were prepped for it on the quiz, and we've done a couple other examples in the homework and so forth. F of negative 6. That's an Algebra 2 question or an Algebra B question. That just means you go to negative 6 and tell me what the y value is. So where is the point at negative 6? It's at negative 2, right there. There's a filled in circle at negative 6. So f of negative 6 equals negative 2. Now this is different though. What is the limit as we approach negative 6 from the left? So again, people are asking, well, what does this mean? Well, right here is negative 6. Which line am I on? I'm on the line that's to the left of negative 6. So you got to know your right from your left here. This will be left. So I'm on this line. But which way am I going on this line? Am I going to the left or to the right? To the right, okay? I'm going towards negative 6. It's not up or down. It's an x value. X is horizontal. X is left and right. Okay, so I'm going to the right on this line. As I'm going to the right on that line, I'm going where? Negative infinity. All right. This one's a little different. This just says x approaches 3. So if we're approaching an x value of 3, that means we're approaching it from both sides. So I got to find where 3 is. 3 is right here. So that means I'm approaching that value from the right and from the left. So now I'm on two lines. And as I get closer to that value on those two lines, I notice that they both meet at the same place, which would be what? Okay, that would be the y value of 1. F of 7. That's an Algebra 2 question. That means I go to the x value of 7, and I figure out what the y value is. Right here is 7. Okay, a common mistake would be to use this. However, it is what? That's an open circle, which means the point does not exist there. However, that is a filled in circle, which means f of 7 equals 1. Now we have the limit as x approaches 7. This is a totally different question than this. These two are not related in any way. So now I'm approaching 7. That means I'm on the line. So here's 7. I'm on the line from the left. I'm on the line from the right. And as I'm getting closer to that x value of 7 from both sides, what y value am I getting closer to? I'm getting closer to -3. Does that y value exist? No. But do I know that on the line? No. Okay. On the line, I'm just approaching and I'm getting closer. I can't tell if it's there or not. And then the last two here, infinity and negative infinity. X is going to infinity. These are the ones that people sometimes struggle with as far as what line am I on. Infinity is out here. It's as far right as you can get. So there's only one line here that's continuing to the right, and that will be this one. So as you're going to the right on this line, going to the right, I'm going to positive infinity. It's going up without end. It's a parabola. On this line, okay, negative infinity. Negative infinity is as far left as you can go. So I need the line that's farthest to the left, which will be this line right here. But what direction on this line am I going? I'm going left. Negative infinity is to the left. So I'm moving left. What y value am I getting closer to? -2. And I need to be able to recognize that that levels off at -2. All right, solving an equation. Anytime it has a square root, things could get a little tricky. So, first, try to get rid of the radical. Start from the outside, work your way in. So I square both sides. I end up with 2x squared minus 9 equals x squared. I'd like to get all my x's on the same side. So I'm going to subtract, I could go either direction here, but I'll subtract the x squared from both sides, which gives me x squared minus 9 equals 0. It is a square, which means it's quadratic, which means you're going to have how many answers, or how many possible answers? Trey? 2. You have 2 possible answers here. Okay? So when I continue to solve this, I could do 2 things. I could add 9 to the other side, and then square root both sides, knowing that every root has 2 answers, a positive and a negative. Or at this step right here, I could do something different, because it's called the difference of squares. Anytime you have 2 numbers that are being subtracted, and they both can be written as a square, that's a type of factoring called the difference of squares. And what does that factor into? Maddie? X minus 3, x plus 3. And then once I have that factored, I just separate these two using zero product property. Go down to B, review there, to solve for x. And when I'm finished solving for x, I should always remember to do what? Check my answers. Okay? So if I check my answers in both of these equations, all right, do they check? They both check?
No.
They don't? The bottom one doesn't? Are you sure? 9 times 2 is 18. 18 minus 9 is 9. Square root of 9 could be 3 or -3, right? So it does check. Okay? All right. Variation. Word problem will certainly be on the test. Okay? So good idea to know how to do this one. Heat experienced by a hiker at a campfire is directly proportional to the amount of wood placed on the fire and inversely proportional to the cube of the distance from the fire. So you have a lot going on there in one sentence. Let's take it step by step. First of all, the heat experienced by the hiker. Let's give that a variable. H, okay, is directly proportional. That means varies directly. That means K times the amount of wood on the fire. So what are we going to call that? Okay, W. And inversely means divided by the cube of the distance from the fire, which would be d cubed. So if I write all of that as a one statement, I would have H equals K times W divided by d cubed. And then they go on to give me some values. The hiker is 26 feet from the fire. That would be your D value. The amount of wood on the fire is if the amount of wood on the fire is doubled, how far from the fire would the hiker need to stand so that he feels the same amount of heat as before? So this one's a little tricky because they're not giving me numbers for everything, which means I'm not going to be able to solve for K. All they're giving me is 26 feet from the fire. So let's plug that in and see what we get. So I have H equals K times W divided by 26 cubed. Okay. And then the other situation they're telling me is that if the amount on the wood or the amount on the fire is doubled, how far will the hiker need to stand to feel the same amount of heat as this? Okay, so that means this needs to be equal to K times 2W, wood doubled, and that's going to be divided by D cubed. So we're trying to figure out what this D value here is. Okay, it actually is a little easier than what it looks. Because we have a K and a W on both sides, they're going to end up canceling each other out. What's 26 cubed? 17,576 equals 2kW over d cubed. So this is a proportion, which means to solve it I can do what? Cross multiply. So I end up with kWd cubed equaling whatever 17,576 times 2 is, which is going to be 38, what? 35. What? 152 kW. I have a kW on both sides, which means that they cancel each other out. So I end up with d cubed equals 35,152. And then to solve that, I just take the cube root of both sides. And I end up with d equaling 32.76. So 32 feet and about 9 inches to get the same amount of heat. If we double the wood, the distance did not double. Some people would think that would be the case logically, but because it's inversely proportional to the cube of the distance, okay, it means it's not going to be a direct proportion. It's not going to be a direct relationship. Okay? All right, great.